So today we're going to look at the second part of the law of sines and law of cosines, and that is the law of sines. We've already discussed this. The objective here of this video is to very simply learn how to use the law of sines to solve non-right triangles. And we already said that in the previous video, but just to kind of re-emphasize, the purpose of having the law of sines and law of cosines is very simply that it allows us to solve for various lengths and angle measures in non-right triangles. I feel like you're going to find the law of sines to be more simple, but who knows? We'll just start taking a look here and see what you guys think. So here's the law of sines. It very simply says there's a relationship between every angle and its opposite side within a triangle. So in other words, if I look at angle A and the side across from it, there's a unique relationship there, and it's the same relationship that occurs between B and little b and angle C and side C, and that is this relationship right here. If I take the sine of the angle, divide it by the opposite side, that ratio is going to be the same in all three cases. Now obviously, when we're solving problems using the law of sines, we're not going to have three different expressions here. Okay? We're obviously going to only use two of them. So they just, again, the whole point of showing you all three is to show you that the ratio is true in all three cases, but when we solve problems, we're just going to pick out two and use it. Okay? So we'll roll with this first example. It says, use the law of sines to solve each triangle. In other words, find every missing piece. Okay, well, the good news is we don't really need the law of sines at all to solve for angle C here. Okay, we go back to first semester, and we recall that the angles inside of a triangle add up to 180. So I do 85 plus 29 and subtract 114 from 180, and I find angle C here to be 66 degrees. And so again, just understanding the process here, I look at this triangle and I say, okay, SOHCAHTOA. And then I realize, wait a second, it's not a right triangle, so I can't use SOHCAHTOA. So I'm reduced to either law of sines or law of cosines, and law of sines is going to be your best bet all the time. If you only know one side, you're going to want to use, you really have to use the law of sines. Okay, so I know for sure I'm using this 9. If I'm using that 9, automatically that means I'm using the 85. So I automatically know one of my ratios here is going to be sine of 85 over 9. Equals. And then it comes down to what I want to solve for first, A or C. Okay, A comes first in the alphabet, so we're going to go ahead and solve for A first. If I'm using A, by rule, that means I'm going to use that 29. So the sine of the 29 degrees over A. Okay, and that's the ratio I'm looking at. And now it becomes a very simple cross multiply and solve. Okay, I cross multiply this way, so I have 9 times sine of 29 equals A times the sine of 85, and I'm just going to go ahead and solve this right now without getting a decimal at all. I'm just going to say I need to get A by itself, so I know I have to divide both sides by the sine of 85 degrees. Divide by the sine of 85 degrees, and so now I know these are going to cancel, so all I'm left with on the right hand side there is A. Okay, so I have already solved for A. A is roughly, because I know I'm going to get a decimal here, just plug all of that into your calculator. So we have 9 times the sine of 29, use parentheses where necessary, and then divide that by the sine of 85. And I'm thinking that A is going to be roughly 4.38. Okay, should be the length of A. And then we look back at the diagram, we say, does that make sense? This angle is 29 degrees, this angle is 85. 85 is considerably larger than 29, so 9 then should be considerably larger than A. Well, I would agree that 9 is considerably larger than 4.38. That should make sense, hopefully. Okay, so I've solved for A, and now I got to go back and solve for B. Okay, obviously I ran out of room here, so I'm going to go ahead and erase all my hoopla here. I'm sorry, not solve for B, solve for C. All right, so A is done. I'm going to erase all of this. If you need it, just pause the video and you'll be able to get it. Let's see if we can try that again. There we go. All right, so now I got to solve for C. Okay, well here's C. If I'm using C, automatically I got to use that 66. Sine of 66 over C is equal to, and then again, my suggestion is always use information that they give you. They gave me the 9, so that means I'm going to use that 85. Okay, so I have sine of 85 over 9, and then again, this just becomes a cross multiply and solve. So I have C times the sine of 85 degrees equals 9 times the sine of 66. Okay, I want to get the c by itself, so I divide both sides by sine 85. Divide by sine 85, and so they cancel over here, so what I'm left with is c is roughly, and again at this point just plug this whole expression here into your calculator. So 9 times sine of 66 divided by sine of 85, and I'm sure if we do all that correctly it should be roughly 8.25. Okay, and again I go back to my problem. I say, does that make sense? Well, this angle 66, that's pretty close to 85, so this c should be pretty close to that 9. 8.25 is pretty close to that 9. I'm pretty sure our answers all make sense. Okay, I don't know if they're 100% right, but I know they definitely make sense in the context of the problem. All right, let's see here. The second guy here, again, it's just solving for various lengths in the triangle. Really, in this one, all we have to solve for is b. That's nice. So my suggestion at this point, pause the video, try it on your own, double check your answer by watching the video. Okay, so I look at this. This is actually an extension problem. I got to do a little bit of work here. Okay, I know this angle and this side, so I know I'm using those for sure. So I have sine 51 over 18 equals, now you'll notice I got to solve for this b, but in order for me to solve for that b, I have to know this angle measure. Well, in order for me to know this angle measure, I have to know this angle measure first, because then I can add up and subtract from 180. So I got to find this angle measure, and the good news is I know that 17. Okay, so if I know that 17, I can solve for angle c. The sine of c over 17 has to be equal to the sine of 51 over 18. Cross multiply and solve. You're going to see a little bit of an extension here. So I have 18 times sine c equals 17 times sine 51. And again, I'm going to go ahead and divide both sides right now by the 18 here so I can cancel that out. And so the sine of c is roughly, and again at this point just plug and chug into your calculator. Okay, so I have 17 times the sine of 51 divided by 18, and I got the sine of c to be roughly, and I would round to quite a few decimal places here because we want to be as accurate as possible. So 73397. Okay, we'll round to 5 decimal places. And so now, again, hopefully you recognize, wait a second, I'm solving for this angle. If I want that angle by itself, then what I have to do is do the inverse sine to both sides. So sine -1 both sides. And so what happens here is we end up with c equals, I should say roughly, and we just do the inverse sine of 0.77 or 0.73397. So the inverse sine of that gets me to 47.22, okay, degrees. So my angle measure here is roughly 47.22. Now the good news is I can use that to find the measure of angle B. Okay, so the measure of angle B equals, now I have 47.22, so 47.22 plus the 51 they already gave me, subtract that from 180, and I know that the angle measure I needed was 81.78. So that's the angle measure I'm going to use. Now I have a lot of stuff on the screen here, so I'm going to go ahead and erase most of it just to clear some room here to solve, to actually do my calculating for B. So get rid of that. Alright, so I know this is my angle measure. If that's this angle measure, I can use that side. And again, I already knew this angle and that side, so those are the two things I'm going to use. You take what they give you. Okay, so when I set this up, I'm going to say sine 51 degrees over 18 equals sine of, now I know my angle here, 81.78 divided by B. Okay, cross multiply and solve. So B times the sine of 51 equals 18 times the sine of 81.78. Divide both sides by this sine 51. Divide by sine of 51. And again, at this point, I have B equals. I would plug this whole thing into your calculator to avoid any mistakes. all at one time. So 18 times sine of 81.78 divided by the sine of 51. And if my calculator is correct, let me do that again. I think I goofed something up. 18 times sine of 81.78 divided by the sine of 51, and I got 22.92 for the length of B there. Okay, so again, you'll notice there was definitely more extensive. I had to solve for an angle measure first, and then I had to use the law of sines again. So I had to use the law of sines twice, once to find this angle, and the second time to find that side. All right, so again, you can see that this law of sines is a fairly straightforward concept, but can get pretty extensive depending on the nature of the question. All right, and then finally, this is the last one we'll look at. It very simply says use the information in the diagram to determine how much closer you live to the music store than your friend does. Okay, so again, you just look at the diagram. Well, here I am. That's where we live. Okay, and this is the friend here. So I really have to use the law of sines twice here. I have to solve for A and for B, and then subtract them to figure out how much closer I live to the music store. Okay, so again, use what they give you. They give me this 34, and they give me that 1.5. So I know I'm going to have sine of 34 over 1.5 equals, and then whatever one you want to solve for first, doesn't matter. Let's go ahead and solve for A first. So if I'm solving for A, I got to use that 81 degree angle. So I have sine 81 over A. I'm going to try to do this in a condensed area here so that we can kind of see what we're doing. So again, I cross multiply and solve. So A times sine 34 equals 1.5 times sine 81. I'm running out of room here. I apologize. Divide both sides by the sine 34. And so the point we end up at is that A is roughly, and I just plug that in now, 1.5 times sine of 81, and divide that by the sine of 34. And I get roughly 2.65. So A is roughly 2.65, and now I'm going to actually just go right beneath that to solve for B. So again, use what they give you. They gave me 34, they gave me 1.5. I'm still going to use that. Now if I'm solving for B, I got to use the 65. So sine 65 over B equals sine 34 over 1.5. Cross multiply, so B times sine 34 equals 1.5 sine of 65, and again from there divide both sides by the sine of 34. I know I'm going rather quickly. If you need to slow this down, just go ahead and rewatch it. So B is roughly, and again at this point let my calculator do my work for me, so 1.5 times the sine of 65, and divide that by the sine of 34, and I get roughly 2.43. So B is 2.43, and so you'll notice if I live 2.43 miles and my friend lives 2.65, well then I am closer obviously, and how much closer? Well, I have to do 2.65 minus 2.43, and that difference, okay, whatever that is, 2.65 minus 2.43, use your calculator, or you could have just, I guess, subtracted in your head because that's pretty easy to do, is 0.22 miles. Okay, so again, just another type of example involving the law of sines that we should be prepared to do heading into our quiz later this week. All right, so again, any questions you have on that, have them prepared, and we'll go from there.